Hello friends, welcome to day 11 of our exciting AI journey. Hi, I am Akshat Goyal. So today let us dive into the ML algorithms like decision trees, random forest and support vector machine. So if you have any doubt, just put in comments and also do subscribe to our channel so that you don't lose any day of the AI content. Let us start with the day 11. So basically, as the name suggests, it uses a tree to come to a decision on classification of a data type. So basically it uses a decision tree. So let us start with the terms, key terms. So basically suppose this is a root node which represents the whole class or family, and when we further divides into two nodes, this is called splitting. And when this subnode further divides into subnodes, this is called as decision node. And the last node, which is the resultant node, which doesn't have any subnodes, is called a leaf node. And suppose if there is a need to remove this, and this is called pruning. So we use a parameter called Gini impurity to find the probability. So how it is calculated? Summation of product of probability of node I into 1 minus probability of node I. So what this means, if this is a pure group, so Gi will be equal to will be 0. Sorry, it will be equal to, yeah, this will be Gini impurity will be equal to 0. And suppose if it's a mixed group, Gini impurity would be equal to .5. So now let us take an example. Suppose you have data set of a molecular cells with size greater than equal to 2 and color equal to yellow. Suppose we need to, and we have different types, sizes and different colors of molecular what do you say, cells. So how we are going to determine the probability, or you can say we need to determine make a model so that we come to a decision. So let us build, let us first consider the condition size greater than equal to 2 molecular size. This is first, this is a root node. So if it's false, so basically this probability is 0. And now this, if this is true, then color is equal to yellow. So if it's true, this probability is equal to 1. If it's false, probability is equal to 0. So this is how. But what is the disadvantage of this algorithm is this tree might lead to lot of branches till the decision is achieved. So it leads to overfitting. And to solve that problem, what we do, we use the concept of maximum depth. Maximum depth is the depth of the tree to which is considered for the calculation, but because of which bias problem is added. So now to overcome this, what we use, Now there's a new algorithm which has come, that is random forest. So whereas our decision tree is used for predicting categories or classification, when we talk about random forest, we have a group of decision trees. So now we'll see how it is random and how it is forest. So it is, group of trees, decision trees. That's why it is called forest. So how it is going to happen? Here we are going to use a set of decision trees with different data sets. We will take a random set of data sets. That's why it is called random forest. Now this technique of splitting into different multiple decision trees is called bagging. Sorry, it is called bootstrapping. And when we take the majority of this decision, what we do take an aggregation of the result. Suppose we are getting results as 1, 1, 0, 1, then we will take the aggregation of this, that will be, probability will be 1. So this whole process becomes bootstrapping plus aggregation, it becomes bagging. Since this distribution of data set is completely random, it is called random, as we discussed this. Now this solves two problems. One is problem of bias, and second, it also solves the problem of overfitting, because rather than chain of nodes, it has multiple decision trees with short number of nodes. So, but we can use this for credit finance, credit prediction, and some other predictions in finance, like loan default prediction. Now third one we are going to discuss is SVM, support vector machine. Now here what we consider is a hyperplane to distribute two sets of data sets. Suppose we have to distinguish cats and dogs. So we have dogs here, data of dogs here, and we have data of cats here. So we need to recognize. So we choose two ends of the data set which are called support vectors. And how we choose them? So that the gap between these two, which is called margin, is maximized. So there can be different types of SVM. First, we have linear SVM. Here we calculate a kernel function. So that means fx is equal to some constant plus sum of the individual variables multiplied by a coefficient. And if it is suppose a polynomial, it's a 3D, 2D or 3D SVM, so we are going to use a polynomial kernel. So how the function goes, kx1 comma x2 is equal to a1 plus a1 is a constant here, a1 plus x1 transpose of x2, and this whole function raised to b. B is a factorial here, or you can say raised to a factor b. And there is another radial bias factorial kernel, and the function will be k x1 x2 is equal to exponential of minus y into Euclidean distance. So Euclidean distance will be this margin, distance of this margin. So this is called Euclidean distance. Now what are the applications? So basically this is widely used in face detection, like we took a case of recognizing cats and dogs. It is also used in handwriting recognition. It is supervised learning because it requires a dataset. We also use it in remote homology detection. They have wide uses. We also use it in hypertext categorization. So we have discussed all the algorithms. So we could see random forest is better than decision trees in some manner, and it solves the problem of bias and overfitting. And now SVM is also solving multi-dimensional datasets. Thank you. Bye bye. Hello friends. So today we have covered day 11 of our exciting AI journey. So I hope you have understood the ML algorithms. And if you have any doubt, just put in comments. Now next we'll be covering day 12, that is overfitting and underfitting, avoiding ML mistakes. So if you have any doubts, just put in comments and do subscribe to our channel. Straightforward, and do hit the like button and also put the notifications on so that you don't lose any of the day content challenge. And yeah, so keep learning AI. So let us learn AI together. Bye bye.